Okay, let's look at number 27. I've done some scratch work here. So my p-value is 0.056, and it's a two-sided confidence interval for mu. Okay, now notice that it says will not contain 0. So if it doesn't contain 0, therefore we want AJ, because that means mu is not equal to 0. And if we want AJ, that means we need to reject HO. All right? So the deal is, if we're rejecting HO, alpha has to be to the right of 0.05. And let me do 0.056. All right, so let's look here. I'm going to start at 99. So if it's 99, then alpha is 0.01. Well, 0.01 is less than. Okay, if it's 0.98, that's 0.02, but that's still less than 0.05. Here's a tricky one, 0.05. 95 is 0.05. That is still to the left. So let's go to B. 93 is 0.07. Look at what happens here if I put 0.07. Now we can reject HO, so the answer is B. Okay, so here they're taking the arm span for both, for high school students, height and arm span, and they want to know that which test, okay, to use. Okay, so my question is to you, first of all, always ask yourself, quantitative or categorical? Now, does it make sense to say that the average height, the average arm span? It does. So therefore, it's going to be quantitative. So that means it's not a two-sample t-test, because that is categorical, and chi-squared and goodness of fit, they're all categorical. So now we're left with two-sample t and the regression. And what do they want to know? They want to know there's a relationship. A relationship. Okay, so the two-sample t-test wants just to see what the difference is, but the t-test for slope, because remember, if there's a relationship, then slope is not equal to 0. It's a regression line. So 28 is E. Okay, let's look at number 29, and we're comparing box plots. Okay, hopefully I can explain this without getting too involved with my dyslexic. Okay, the interquartile range are both the same. I hope that you can see that that is not true. And the range for B is greater. The range is the same. Okay, so now let's go talk to C. There are more petal lengths that are greater than 70. Okay, so what do we notice here about 70? That's roughly Q3, right? And what percent is Q3? That's 25. That's 75%. So that means here we have 25%, and here we have 25%. Okay, I can't draw the percent sign here. All right, so 25%. So they say here there are more petal lengths greater for 70 for species A. But do you see that that's not true? Because here, if this takes 25, this might be 20% for A. Or it might be 18% for A. But it's less than 25 because 25 happens here. So it's not C. Okay, so now let's erase this and we'll go to the next guy. All right, so now let's go to D. The petal lengths are greater than 40. Well, what do we notice here about 40? 40 looks like my median. So, and we're talking about greater than. So we got 50% here. But look at here. This here is 50%. So who knows what this might be? This might be 45. It might be 40. So there are more lengths that are greater than 40 from B. Well, that's not true, because what did I say? That this is probably 40 or 48. So it's not that. So let's, before I go with E, let's make sure that E is correct, okay? All right, it says now they're talking about 30. So here we're talking about Q1. So this is 25%. And this is going to, here is 25%. All right, so they say there were more petals less than 30 for the B than in A. So if this is 25%, do you see that this might be 30%, or it might be 35%? So that gives me more. So the answer is E. Okay, hopefully you read number 30, and we're talking about voting, and first N is 50 and then it's 200. Okay, so let's just go do this. So you got 50% of voting for one guy over 50. You take the square root, and let's do 50% of the second guy, this time divided by 200, and you take the square root, okay? So this gives you 0.07, and this gives you 0.035. And what do you notice here? That as when n increased, okay, from 50 to 200, what happened to my square root? It halved, right? It halved. And remember, the formula is going to be p hat plus or minus z times your standard error of p hat, which is this guy right here. So it's going to half, so the answer is B. Okay, so I'm going to erase all this before I start the next problem. Okay, so hopefully you read number 31, and I kind of outlined it, okay? I was trying to see. Remember blocking? Blocking. It's just like stratify. So stratify is the sampling, as blocking is the design. And we block because we think that something will affect difference. For instance, working out. Okay, I think that working out for males is different than working out for females. So if I wanted to see if the weight loss program would work, I would want to separate the males from the females. So that's because there's a difference here. They say that car size has something to do with it, but car type does not. So size. So the answer is A. Hopefully you thought that was easy. Okay, so 32 is about increasing power. And so I did some notes. I know, and you guys need to look at this. Power. So if I want to increase power, I decrease beta. But if I want to decrease beta, I have to increase alpha. All right? So it has nothing to do with it being a two-sided or one-sided test. Well, if alpha is originally 0.05, 0.01 is decreasing alpha. That's not going to work. Okay, and so the next two deals are about sample size. It has nothing to do with beta, and it has nothing to do with alpha. So what do you remember about sample size? Now, if we increase n, okay, we will decrease beta, we will decrease my alpha, all right? So we start off with 100. So I want to increase it. So I don't want 50, I want 200. And you see here they got a spelling mistake. It should be increase. So the answer for number 32 is E. Okay, hopefully you can read this problem better than I can with this gray, but hopefully you guys don't have this gray box on top that I have. All right, so the deal is here is that we're taking 100 samples. And we don't know what size the samples are. We just know that they're size n. Okay, they're size n. And they said the truth is 0. All right? And then they also say the very last question is, which simulated sampling distribution is associated with the best estimate of this parameter? All right, so if we want the best estimate, so that means that it should be unimodal around 0, correct? Now, you can't see E here, but if you go to the next page, you see how E is down here at the bottom. Okay? Well, E is out because, look at here, it's not unimodal at 0. So let's just go back. We'll just forget about that page. So that really gives us who? Who is unimodal at 0? It's just B is, right? And you notice how pretty tight it is? It has a small standard deviation, okay? Not a lot of variability here. So the best guy for this is B.